Good day, guys. Let's see another arc length problems for mathematics. This time again for parametric equations. So it says calculate the arc length of the curve y equal to sine cube theta and x equal to cos cube theta between theta equal to 0 to theta equal to pi over 2. So once your problem is defined parametrically, even if they don't use the word parametric, you will see that x and y are given in terms of another variable. That tells you that it's parametric. So in that case, your limits do not take you to your formula, because your formula will be something that has the derivative of x and derivative of y, as you see on page 7 of your formula sheet. So I'll capture my formula as the integral from theta 1 to theta 2. If you're an N6 student looking at your formula sheet, you will see u1 to u2. Then I'll have dx over d theta, and your formula sheet will be showing dx over du squared. Then you also have dy over d theta in the place of dy over du squared, then d theta in the place of du. So that's my formula, and that formula will then take me slowly but gently through the integration process. So I have to differentiate x with respect to theta, square it. I do the same thing with y. Then I pull the two together, simplify before I come to that. So now let's start with, I can start with my x is fine. X is given as cos cube theta. So here, this is where if you are not really familiar with the meaning of this, you might get in trouble. When they have cos cube theta, what it actually means is that it's cos theta, or that cube, which should now help you see that when you are doing derivative, you must be doing the chain rule. So if I'm doing the chain rule, I differentiate the inside and I differentiate the outside. If I start with the outside, I will multiply 3 there, then I have cos theta, or that square, then multiplied by, if I go to the inside and differentiate cos, it gives me negative sine theta. So that's how you must do it, with the help of the chain rule. So if you can't interpret this to look like that, and you will not be able to get the right derivative, and once the derivative is wrong, you are in trouble. With arc length, guys, make sure your derivative is always right. So I can now go on and do my squaring. If I square the derivative of x, that means I'm squaring all of this, 3 in bracket cos square theta into minus sine square. So that is what I'm squaring. So that means the square of 3 is 9. If you square cos square, it gives you cos theta to the power 4. Then if you square a negative, it becomes positive. So this becomes sine theta, or that square. So that can also be written as 9 cos to the power 4 theta, then sine square theta. So that is what I've done for x. I'll go through y and follow the same procedure. So y is equal to sine cube theta, which I must understand it as sine theta, or that cube. Then I follow the same procedure as I did for x. So dy over d theta is the chain rule. If you differentiate the outer function, you get 3 sine theta, or that square. Then the inner one gives you cos theta. Once you differentiate sine, then you do your squaring as the formula requires. You get dy d theta, or that square would mean that I'm squaring 3 sine theta square multiplied by cos theta. That's what I'm squaring. If you square 3, create a 9. You square sine square, gives you sine theta to the power 4. Then you square cos, it gives you cos theta, or that square, which can now be written as 9 sine to the power 4 theta cos square theta. So guys, that is how we simplify the two items hidden under the square root. Then it's now time to pull the two together with the help of the addition sign. So I get sine dx d theta square plus dy d theta square is equal to, I'm adding these two. I don't know which one should I take, whether I take this or take that, but they are the same. So you have 9 cos to the power 4 theta sine square theta, then plus 9 sine to the power 4 theta cos square theta. So looking at those two, there must be a common factor. Whenever your problem is defined parametrically, the nice thing is that at this stage, you must end up with a common factor. So I see 9 to be common. I see sine square theta, because sine square is here and there. Then I also see cos square theta. So in bracket, if I take out 9 sine square cos square, then I'm left with cos square theta there. Then if I take 9 sine square cos square, I'll also be left with sine square theta there. Then the item in bracket is our identity, which is equal to 1, which in the Math N6 formula sheet is formula number 1 on page 1 of your Math N6 formula sheet. So that is how simple it breaks down to. Then you realize that this item can be handled under the square root sign in the formula. So it's therefore time to start integration. Theta 1 is the lower limit, which is 0. Theta 2 will be the upper limit. Then I'll get the square root of 9 sine square theta cos square theta d theta. So that is what I get, which if you take that square root, the square root of 9 is a 3. 3 are a constant. You step out. Then the square root of sine square is sine. The square root of cos square is cos. Then d theta. So that's what we are left with to integrate. So what we need here is just our integration techniques. It all depends on how equipped you are. But looking at it, it's a product. Once you are integrating a product and you can differentiate one item, you create the other, then that's U substitution. You see, if I differentiate sine, I get cos. So I can say let U be equal to sine theta, look for du d theta, and do those things. But as an N6 student, each time you see U substitution, the fastest way to go through it is to go through the power rule. We don't usually have time to be doing U substitution as if we are still in N4. So, but if you have that time and energy, it's fine, it's not a problem. So, because I'm sure that it's U substitution, how was I sure? You see that you've got a product, you differentiate one item, you can create the other. If I differentiate sine, it creates cos. So, that is my U substitution. If I can rearrange that integral to fit there, then I'll use that formula on the right to put my answer. So, let's go. If I'm doing my integral, I'm trying to rearrange that. Whichever one I want to call my U should fit into the position of f. So in this, since the derivative of sine gives us cos, sine will be the perfect person to be u. The power of sine is 1. That takes the place of n. Then when I differentiate sine, it creates, because the formula needs you to get a derivative. If I differentiate sine, I create my cos d theta. Then I've used my left side to arrange to look like the problem. Then I have to compare the two, whether they are still the same, so that I do an adjustment outside. When I look at it, it's exactly the same thing, there is no change. So I just need to use the right side now to write my answer. So if I'm writing my answer, I'll get 3 in bracket the sine of theta to the power 2, because the power must increase from n to n plus 1, then divided by 2 from 0 to pi over 2. So that's my integration. I can now put my limit, starting with the upper limit. So that is the sine of pi over 2, or the square, and 2, that's my upper limit. Then my lower limit will be the sine of 0, or that square of 2. So if you're familiar with your sine graph, you know that your sine graph starts from the origin. So that tells us that the sine of 0 is 0. So we only concentrate on the upper limit in our calculator. So when you go to the calculator, I'll calculate the sine of pi over 2 all that square, then multiply my answer by 3. So let's go through that in our calculator. 3 over 2, I can take it out to be a constant, so I'm looking at the sine of pi on 2. That's what I'm getting. Then I square that. That gives me 1, and multiply by 3 over 2. The answer is 3 over 2. So what I've seen is that by using my calculator, I've seen that my arc length is equal to 3 over 2, because this part is 0. That one gives me 3 over 2 unit. And guys, another thing you must not forget is that with integration, we always make sure we put our calculator in radians so as to arrive there. If your calculator is not in radians, you'll be surprised that I'm getting 3 over 2, but you're getting something else. So guys, thank you very much. That's how to get the arc length